9.81 what?
Meters per second squared.
Meters per second squared. Where did that come from? So what is, when we talk about the force of gravity here on Earth, we also use this, which is puzzling. It's the exact same thing, but what is our equation for it usually?
The question is that 9.1 or just 9.8?
That's 9.81.
Okay, I was making sure.
Thank you for the clarification. Force of gravity. When we plug this into a free body diagram, what does this? What equation do we use?
Mass times gravity.
Mass times gravity. This is right. This is Newton's second law. That's all that is. This is except for we're talking about our acceleration is acceleration. So we need this guy. And let's talk about the mass of Mr. Sandoval, because I'm trying to figure out what is the force that I feel as I'm accelerated towards our Earth. Okay, and so we're gonna plug this into our equation that we just got. So I'm just gonna, let's see here. We have the gravitational constant. We have mass 1, which is gonna be me, Mr. Sandoval. Mass 2 is the mass of our Earth over the radius.
Are we doing this math now?
Are you in space or are you standing there?
I'm standing on Earth. Excellent clarification.
So I guess it's the distance to the core, like your center.
Here I
know,
am.
it's pretty nice for you guys.
Doing some sit-ups.
You're pretty tall.
Actually,
You're pretty tall. You're like,
okay. So what
Earth
is
at least
this?
like 5
Right.
miles.
We're looking at the center of me. So this is right around my navel, my center of gravity, to the center of the Earth. How can we best approximate that?
2 miles.
Well, you're a giant.
4.5 the radius of the Earth. Half the radius of the Earth.
All right. So right here we've got the radius of the Earth, which is approximately 2,000 miles.
It's around 2.
Okay. If I was 1 second, Jackson, or go ahead.
I don't want to sound dumb, but do you always represent that kind of radius with like that kind of squiggly line?
That's approximately.
Oh,
Is
like that?
approximately? Because like on the other one you did like a squiggly line too.
Oh no, I'm just showing you from where. I don't know.
That's like
you
one of-
can
it's like
also
one of-
do a something like.
It's like one of those lines teachers do the past like 13 tests. Like they have to do that line.
Yes.
She's just showing.
Project.
Y'all really did that one? That's stupid.
So, gentlemen, let's stay focused. If I am standing on the top of Mount Everest, okay, how much higher am I going to be above sea level?
4.
Like,
I gave it
However
like
tall
1.
Everest is.
Okay.
Plus 1.
Would that really matter though compared to like how big the Earth is?
Exactly. So it may be plus or minus 5 miles, which is about 0.4%. So what we're gonna do is we're gonna cross this out.
Oh,
we're gonna
we crossed out like the fish.
Whoa.
I didn't even write it.
this radius
He's just bragging at this point.
is just the radius of the Earth. Okay, we're gonna approximate that because it is such a small percentage. We said about if we're doing less than 10% error, then we're pretty good.
And you see this? I have a pen, so I can't really erase it. It's been on there forever.
Dang, it's okay. Mistakes help me improve.
True.
Mistakes help me forget to believe your lies.
Alright, so I'm going to do a couple things really quickly. What I'm going to do is I'm going to divide both of these by the mass of Mr. Sandoval.
Nice.
So are we writing this?
Yes, go ahead and write this. What I'm going to do over here is I'm going to do the exact same thing. I'm going to divide by the mass of Mr. Sandoval. Okay, and that cuts that out. This is a little tough to see. Do you all see anything?
G equals big G.
Oh, just G times ME over R E squared equals 9.1.
So
I'm tripping.
we have the force of gravity divided by Mr. Sandoval's mass.
Substitute this.
Okay. So this equals G, and this equals big G times the mass of the Earth divided by the radius of the Earth squared, what can we say? What two things can we kind of pull together?
G
equals
equals big G times the mass of the Earth over the radius of the Earth.
Oh, so that's Earth. Oh my goodness.
So whenever we want to figure out the force of gravity on the surface of a large planet, you can find the force of gravity that you create yourself. You do create a small gravitational field, tiny compared to the Earth. This is all we have to do. Okay, this is contingent on a couple things. Number one, that I am standing on that surface. Okay, again, we're thinking about, well, this is the radius of the Earth, and we ignored, right, the radius, whatever it took to get to actual my center of gravity. Okay, so it's like the gravitational or the force of gravity, acceleration due to gravity here on Earth is 9.81. We could also figure out, what that is on Pluto, or if we are standing on the surface of the Sun. Although you have other issues at that point.
What are you doing on the sun?
It's at night, it's okay.
But
The sun's off.
so this is contingent on you like standing on the surface of a large planet.
What would
Sure, we'll do
a million lines or the sun?
Yes, Jack.
So then why doesn't everything in space just go short?
They're too far apart.
But no, the closest star is 400 light years.
But like if they're all like